Hi there. We're going to completely solve this CBSE Class 10 Term 2 Sample Basic Mathematics exam from the 2021-2022 academic year. For my American viewers, CBSE is the Central Board of Standard Education in India. So this is akin to a Term 2 10th grade math exam, if I understand correctly. Now, we've got some general instructions about the exam. It's split up into 3 sections. You'll notice a couple mentions of internal choice, which just refers to a question that has 2 options. You can do one part or you can do the other part. We will, of course, complete all parts of all questions with no calculator, and I hope you'll find my solutions helpful. Timestamps are in the description if you want to jump around to a specific question. I will also leave a link in the description so you can go download this exam for yourself and give it a try. I've copied each question and pasted it into its own page so that we have more room to go through our work. So here is the start. We've got an internal choice for this first question, but we will of course do both parts. We want to find the roots of the following quadratic equation: 3x squared minus 7x minus 6 equals 0. So we're just trying to solve for x. Now we can do this by factoring, and in order to factor this quadratic expression, you want to know the sort of basic frame, how the factor is going to have to look. Often our factorization would look like this, with x and x in order to get x squared, but our leading coefficient isn't 1. In this example, the leading coefficient is 3, which means we need the product of these x terms to be 3x squared. Thankfully, 3 is prime, so we still only have one option. We're going to need a 3x and an x. Then the only question that remains to complete the factorization is what goes here and what goes here. Whatever numbers go here, they're going to have to multiply to -6. So we don't have that many options, 1 and 6 or 3 and 2, and one of them will have to be negative. I would jump for 3 and 2 because I notice that 3 times 3 is 9, which is 2 away from 7. So I think that's going to help us get the middle -7x term. So I'm going to go ahead and have x minus 3. That way we get minus 9x, and then I'm going to have plus 2. That way we get a plus 2x, and so minus 9x plus 2x gives you minus 7x. You can check this if you want to do the multiplication. You'll see it works out. This is a valid factorization. And this is equal to 0. So by the zero product property, we have that 3x plus 2, this factor, must be 0, or x minus 3, this factor, must be 0. The first equation gives us a solution of x equals -2/3, and the second equation gives us a solution of x equals 3. And those are the roots of the quadratic equation. So question 1, it's worth 2 marks. You could get those by doing this part or this part. We did the first part. Let's go ahead and do the second part now, just for the sake of completion. We want to find the values of k for which the quadratic equation 3x squared plus kx plus 3 equals 0 has real and equal roots. For a problem like this, it's helpful to know what the discriminant of a quadratic equation is. The discriminant is, well, think of it this way. If you apply the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a, the discriminant is the thing under the square root, b squared minus 4ac. The discriminant can tell us how many solutions a quadratic equation has and what type. If the discriminant equals 0, then notice the plus minus in the quadratic formula doesn't actually do anything, and so in fact we have only one solution in that case. So if we want to have real and equal roots, equal really means that there's only one root, we need the discriminant to be 0. That way we won't have a plus and a minus solution, since this is just 0. We'll just have one real solution. it would be a real solution with multiplicity 2, and that's what we mean by equal roots. So let's write the discriminant of this quadratic equation and set it equal to 0, and then solve for k. The discriminant is b squared minus 4ac. b is the coefficient of the x term. The coefficient of the x term is k. So we have k squared minus 4 times a. A is 3, the coefficient of x squared. And then multiply that by c, which is the constant term, which is also 3. And we're setting this equal to 0. We want this, the discriminant, to equal 0. So we have that k squared is equal to 36, because 4 times 3 times 3 is 36. Then add it to both sides. And then we just need to take the square root of both sides. So k is plus or minus the square root of 36, and of course that means k is plus or minus 6. If k is 6 or negative 6, this quadratic equation will have real and equal roots. And just to make sure you see what we mean, if k equaled positive 6, for example, then this equation would be 3x squared plus 6x plus 3. You could divide both sides by 3 to get the x squared plus 2x plus 1 equals 0, and then we could factor it as x minus 1 squared, and that squared factor tells you that we've got equal roots. Question 2. 3 cubes, each of volume 64 centimeters cubed, are joined end to end to form a cuboid. Find the total surface area of the cuboid formed when we do this. First thing we should probably note is what the side length of these cubes are. If the volume is 64 centimeters cubed, then of course we can find the side length by taking the cubed root of that, since to find the volume of a cube, you've got to cube the side lengths. And of course, if we say, let's write it like this, s cubed equals 64, take the cube root of both sides, s has to equal 4. So the side lengths of all of these cubes that are being joined together, they're all 4. Now here I've sketched a cube just to help us answer the question, and the idea is that we're sticking 3 of these together and forming a shape like this. Now we just need to find the surface area of this shape, and the only slightly tricky part here is that a few of these surfaces of the cubes have been covered up since they've been joined together. Then how are we going to find the surface area of this solid? Well, let's focus on the surface area of these faces first. All of those faces are just simple rectangles. Now, the length of these rectangles, since they're made up of these 3 cubes, will have to be 4 plus 4 plus 4. That's the length of one of these rectangular faces, and that, of course, is 12. And then the width of each of these rectangular faces is just a side of the cubes that make it up, and so the width has to be 4, as this says here. So each rectangular face, of which there are 4, there's one here in the front, one in the back, one on top, and one on bottom. Each of those rectangular faces has an area of 12 times 4. So we'll write this. Surface area equals, let's first add up those 4 rectangular faces. There's 4 of them, so we'll have 4 times their area, which is 12 times 4, length times width. Now we just have to add the areas of the ends. The ends are just faces of our original cube, and that, of course, has an area of 4 times 4. Those are just squares on the end. So we'll add 2 copies of that because there are 2 ends. 2 times 4 times 4, that's just 2 times 16. And then 12 times 4 is 48, and 4 times 48 is 192. So 192 plus 2 times 16, that's plus 32. And so this is 224. And let's not forget our units, which are centimeters squared, because we're talking about surface area. So centimeters squared. That is the surface area of this cuboid. Next, question 3, which is worth 2 marks. An inter-house cricket match was organized by a school. Distribution of runs made by the students is given below, and we want to find the median runs scored. Now, the difficulty here is that we're finding the median not of a raw data list, which is really easy, it's just the number in the middle. Here, we have to find the median for grouped data. And so, I have pasted the formula here for the median in this situation. The first part of this formula for the median that we want to calculate is this n over 2. That's the number of data values divided by 2. Now, we can calculate big N, the number of data values, by just adding up all of these frequencies. 4 plus 6 is 10, plus 5 is 15, plus 7 is 22. So n over 2 is 22 over 2, which is 11. That's the first part of the formula we need because that tells us which interval the median is in. This tells us that 11 is like halfway through the list of values. So if we imagine counting up 11 to see where we end up, we would count 4 in this interval, and then we'd count up to 10 in this interval, and then the 11th data value would be in this interval between 40 and 60. That then tells us that this L, which should be the lower bound of the interval containing the median, is 40, because the interval containing the median is this one, and the lower bound there is 40. So I'm just going to write this fraction bar that we know needs to be there, and then out here we'll put the lower bound 40. Now in the numerator we have to subtract CF. That's the cumulative frequency of the interval preceding the one that contains the median. So the cumulative frequency of this interval. To find cumulative frequency, we have to add up all the frequencies up to and including this interval. That just means 4 plus 6. So that cumulative frequency that we're subtracting is 10. Then divide by f, that's the frequency of the interval containing the median, which is 5 here, and then multiply by the interval widths, h. The interval widths for this group data is 20. Each interval has a width of 20, so we multiply by 20. Now we just have to finish this calculation to find the median. It's going to be 40 plus 11 minus 10 is 1, and 1/5 of 20 is 4. So 40 plus 4, which is 44, and that is the median of the group data. Question 4. Find the common difference of the arithmetic progression 4, 9, 14, and so on. And we'll read the second part in just a minute, but let's do the first part first. An arithmetic progression is very simple. It's just a sequence of numbers where the difference between consecutive numbers is the same. So, if the difference between the first two numbers is 5, as it is here, that's the difference between any consecutive pair of numbers. So, we'll write CD, the common difference, is equal to 5. To find that, we just subtract the first term from the second term. 9 minus 4 is 5. If we were to continue this arithmetic progression, the numbers would be 4, 9, 14, go up 5, 19, go up 5, 24, 29, and so on. Second part of this question, if the first term changes to 6, but the common difference remains the same, write the new arithmetic progression. Very simple. The first term is now 6, the common difference is still 5, so we need to go up 5 for each new term. That is 6, 11, 16, 21, and so on. Question 5. The mode of the following frequency distribution is 38, and we need to find the value of x, which is the frequency of items in the 40 to 50 interval. To answer this question, of course, we're going to need the formula for the mode of grouped data. Here it is, so let's set it up. And we'll set it equal to 38, which is the given mode, and then we'll just have to go ahead and solve for x. Let's start with L. L is the lower bound of the interval containing the mode. We're told that the mode is 38, so the interval containing the mode is this one from 30 to 40. Thus, L, the lower bound of that interval, is 30. And now we just have to add this fraction. F1 is the frequency of the interval that contains the mode. That interval, again, is this one from 30 to 40, and the frequency of items in that interval is 16. So we have 16 minus F0 is the frequency of the interval preceding the one that contains the mode. That is the frequency of this one right before the mode. And the frequency there is 12. So we subtract 12. Now in the denominator, we have 2 times F1. We already said F1 is the frequency of the mode interval, so that's 2 times 16, which is 32. And then we subtract 12, the frequency of the interval preceding the mode interval. And then we subtract F2. F2, as you might guess, is the frequency of the interval following the mode's interval. The mode's interval is this one, so the following interval is this one, and its frequency is x, the number we're looking for. So subtract x. Then the last thing, we have to multiply by h, that's the class interval width. And in this case, the widths of our intervals are 10. 10 to 20, 20 to 30, and so on. The widths are 10. So we'll write multiply by 10. And what is this equal to? Well, it's the mode, and we're told that the mode is 38. So this equals 38. Now let's go ahead and subtract 30 from both sides and do a little bit of simplification. 16 minus 12 is 4, times 10 is 40. So I'll have 40 here in the numerator, divided by 32 minus 12 is 20. So in the denominator, we have 20 minus x. And then 38 minus 30 is just 8. To finish solving the problem, we just got to do some basic algebra. Let's multiply both sides by 20 minus x to find that 40 equals 8 times 20 minus x. And then we'll divide both sides by 8 to get that 20 minus x equals 5. Then if we add x to both sides and subtract 5 from both sides, we'll find that x is equal to 15. And that is our answer. Next, question 6. This one's pretty easy. We're given that xy and mn are the tangents drawn at the endpoints of this diameter DE of the circle with center O. We want to prove that xy and mn are parallel. You should notice that DE, as told to us, it is a diameter. So it's like a single line that's a transversal of xy and mn. So what we want to do is show that these alternate interior angles are congruent. If we can show that we've got a pair of congruent alternate interior angles, that will be proof that xy and mn are parallel. Doing this is quite easy. Since DE is a diameter, it's made up of 2 radiuses, or radii. So, for example, the radius OD must be perpendicular to xy, because xy is a tangent, and tangents are perpendicular to the radiuses that meet them at the point of tangency. So this angle here, ODY, has to be 90 degrees. The radius is perpendicular to the tangent. Similarly, the radius OE is perpendicular to the tangent MN, and so we can say that this angle here is 90 degrees. Radius is perpendicular to tangent. And so we have a pair of alternate interior angles that are congruent, thus XY must be parallel to MN. My dots here, by the way, just indicate that a similar argument as given here is used to show that this angle is a right angle. So we're good to go. Question 6 is actually one of the internal selection questions where there are two problems you can choose from, and this is the second problem. So let's do this one. It's a cute problem. In the given figure, a circle is inscribed in the quadrilateral ABCD. This means that all the sides of the quadrilateral are tangent to the circle. We're given that AB equals 6 centimeters, BC has a length of 7, and CD has a length of 4. We just want to find then the length of this other side, AD. What's important to note here is that if we have a tangent to a circle from a point, like here from the point B, we've got this tangent BC and this tangent AB, where the tangent intersects the circle from this point outside the circle, we get congruent segments. So if, for example, I call this point P and this point Q, I know that BP has to be congruent to BQ. And if we label the other points R and S, just for another example, we know that CQ is congruent to CR. This is just a fact of geometry that we've got to know. Now, I'm going to set up an equation involving these congruent pieces of the quadrilateral. Let me show you what I mean. First, I'm going to write BQ. That's this segment here. And we know that's the same as BP, so I'm going to write BP beneath it. I'm going to continue in this way, adding pieces to both of these lines, pieces that are congruent. So next, I'm going to add CQ in the top line, which is the same as CR, so I'll add CR in the bottom line. Now, I haven't chosen CQ arbitrarily. Notice that BQ plus CQ gives us a whole side of the quadrilateral whose length we know to be 7. So I'm going to continue in this way. You'll see how it works out. Next up, I'm going to add DS to the top line, and I know that DS is the same as DR, so I'll add DR to the bottom line. Finally, we'll add AS to the top line, and I know that AS is the same as AP, so we'll add AP to the bottom line. All the pieces I've added together here are equal correspondingly. These are equal, these are equal, these are equal, and those are equal. So these two sums have to be equal. Now, though, we can do some really nice simplification. Let me go ahead and move this over to the left, and we'll write a simplified version over here on the right. And I'll go ahead and write that simplified version in purple. First, BQ and CQ, we know that's just this side, BC, that has a length of 7. So I'll replace that with just 7. And then CQ and DS plus AS. Let's look at those. DS plus AS. That's the side AD. AD is the thing that we're trying to find. We don't know what it is, so we'll just have to leave it as AD. Now this is equal to the second line. Let's simplify the second line. BP plus CR, that's not something that we know offhand. Let's look at CR and DR. CR and DR is the side CD, which we know has a length of 4. So we can replace those two things with 4. And that just leaves BP and AP. Together, BP and AP make up the side AB, which we know to have a length of 6 centimeters. So we can replace those two things with 6. Finally, we have that 7 plus AD, and remember AD is what we're looking for. 7 plus AD equals 10. Hence, we know for sure that AD, the missing side, must be equal to 3. And we'll throw our units on there, 3 centimeters. That's the answer. Question 7 is worth 3 marks. It's another arithmetic progression question. We're given an arithmetic progression. We're told it has 40 terms. It's this progression, 5, 8, 11, and so on. We can tell clearly the common difference is 3, and of course the first term is 5. We're asked to find the last term. Not too difficult, so here's how you do it. Let's write A40 to represent the last term of the progression, which is the 40th term. To find the 40th term, we need to take the first term, which is 5, and then think about how would we get to the last term. Well, 5 is the first term. We need to go past 39 more terms, or go up 39 more steps, in order to get to the final 40th term. And each step requires us to go up by the common difference, which we can see is 3. So we need to go up 39 steps, and each step is the common difference of 3. And so we just have to do the math. 39 times 3 is 117. Add that to 5, and we get the last term is 122. Then the second part of the question asks us to find the sum of the last 10 terms. There's a really nice formula for summing consecutive terms in an arithmetic progression. We need to take the number of terms being summed, which is in this case 10, and divide that by 2. Then just multiply this by the sum of the first term in our sequence that we're summing and the last term in the sequence that we're summing. Now, we're adding up the last 10 terms, so the very last part of that sum is going to be A40, the 40th term, which we just figured out is 122. What's going to go here is the first term in our sum, and we're summing the last 10 terms, so this would have to be the 31st term of the sequence. This is because the last 10 terms would look like this: A31, A32, and so on, all the way up to the 10th term in this particular sequence, which happens to be the last term of the progression, A40. So to find that 31st term, we proceed very much like how we did before. A31 is going to be the first term, 5, but then we have to go up 30 more terms to get to A31. We have to go up 30 more terms, or 30 steps, and each one involves a common difference of 3. And so in total, we see this is 5 plus 90, or 95. That's the 31st term. So right here is going to go 95. And now we just have to do the math to calculate what this is. 10 over 2 is 5, and 95 plus 122 is 217. And 5 times 217 is going to be 1,085. And that is our answer. 1,085, that's the sum of the last 10 terms of the progression. Question 8 is another internal choice question. We could do this one or this one. We will, of course, do both. Let's start with the first one. A tree is broken due to the storm in such a way that the top of the tree touches the ground and makes an angle of 30 degrees with the ground. So let's start setting up our picture here. I'll draw the ground as this brown line, and let me try to make it straight like that. And we're told that the fallen tree, it's going to make an angle of 30 degrees. We're given the length of the broken upper part of the tree, and we're going to want to find the height of the tree before it was broken. So an interesting setup here. The idea is that we had a tree, and then part of it breaks and is going to be touching the ground at an angle of 30 degrees. So to model this really simply, we've got the bottom half of the tree that's still attached to the ground, and then the upper part broke and fell over, and so now maybe it looks something like that. It's making an angle of 30 degrees with the ground. The upper part, like I said, is 8 meters. That's this one, the upper part that broke. It's got a length of 8 meters. Now we're asked to find the height of the tree before it was broken, which means we need to find the height of this lower part that's still attached to the ground, and then add that to 8. And that's going to tell us how tall the tree was when it was still standing upright. And it's really just an easy trig question. We should assume this is a right angle. The tree is attached perpendicularly into the ground. And so we can say that sine of 30 degrees, that's going to be the ratio of the opposite side to the hypotenuse, and we'll call this opposite side x. So sine of 30 degrees is going to equal x, the opposite side, over the hypotenuse of our right triangle, which has a length of 8. And then, of course, you've got to know what sine of 30 is. 30 is the same as pi over 6. 30 degrees is pi over 6 radians. And the sine of pi over 6 is 1/2. So x over 8 equals 1/2. And it's pretty easy to see that means x must equal 4. In this case, we're talking 4 meters. So if this part of the tree that's still attached to the ground is 4 meters, and the part that broke off is 8 meters, then the height of the tree before it was broken must be 12 meters. Now, here is the other problem we could have done for question 8. Two poles of equal height are standing opposite each other on either side of a road 80 meters wide. Starting to set up our picture, here are our two poles, and they are standing opposite each other on this road that is 80 meters wide. We're told that from a point between the poles on the road, the angles of elevation of the top of the two poles are respectively 60 degrees and 30 degrees. So let's start to sketch that. Maybe the point is right here, and the angle of elevation to one pole is 60 degrees, and the angle of elevation to the other pole is 30 degrees. And we are asked to find the distance of the point from the two poles. Those distances, of course, will be different, so we've got two distances to find. How far away is this point from the left pole, and how far away from the right pole? What's going to be useful in this problem are the properties of a 30, 60, 90 right triangle. And so I've put this diagram here that tells us how the sides of a 30, 60, 90 triangle relate to each other. Notice, since we assume these poles are sticking vertically out of the ground, these are both right triangles, and so they must both be 30, 60, 90 triangles, and so we can use this diagram to inform us about both of them. Let's call the distance between the point and the leftmost pole x. So we'll call this right here x, and then of course the distance between the point and the rightmost pole must be 80 minus x. We know that the poles have equal heights, but we don't know what that height is. Let's call it h. Now, h is something that both of these triangles have in common. They both have these heights of h. So let's try to set those equal to each other in a way that will let us solve for x. If I want to try to get the height involved, and of course I also want x involved, you may think about the tangent function. Tangent of 60 degrees is the ratio of the opposite side to the adjacent side, which is h over x. So let's write that. Tangent of 60 is equal to opposite, which is h, over adjacent, which is x. But we can use this diagram of the properties of a 30, 60, 90 triangle to remind us what the tangent of 60 degrees is. Tangent of 60 degrees is opposite over adjacent. That's x root 3 over x, which is, of course, just root 3. So tangent of 60 is root 3, and this is going to tell us that the height of the pole must be root 3 times x. Now we can do a similar thing with this other triangle to get another expression for the height. So now, focusing on this triangle, we can write that tangent of 30 equals the opposite side, h, divided by the adjacent side, which has a length of 80 minus x. And then, remembering our properties of 30, 60, 90 triangles, tangent of 30 has to have a ratio of x to x root 3, as in 1 over root 3, since the x's would cancel out. So this is equal to 1 over root 3. That's the tangent of 30 degrees. And so this tells us then that h is equal to 80 minus x divided by the square root of 3. Now we can set this expression for h equal to this one to solve for x. Setting up this equation and then multiplying both sides by the square root of 3 is going to give us that 3x equals 80 minus x. Then if we were to add x to both sides, we'd have 4x equals 80, and so x must be equal to 20. Thus, this point is 20 meters away from the left pole. Let's put our units there, meters. It's 20 meters away from the left pole, and it is 60 meters away from the right pole, and that's the answer. Question 9, it's worth 3 marks, and it's really easy. PA and PB are the tangents drawn to a circle with center O. We're told that PA has a length of 6 centimeters, and angle APB is equal to 60 degrees. Then we want to find the length of the chord that goes between the points of tangency, this chord here, AB. We should notice that we've got a triangle here, triangle ABP, and we can actually show quite easily that it's an equilateral triangle because we've got two tangents to a circle from a common exterior point. In this situation, which came up in a previous question, these segments have to have the same length. If we've got tangents, 2 of them, from a common external point, they've got to have the same length. So this piece, BP, has a length of 6 centimeters. This means we've got an isosceles triangle, and in such a triangle, the angles opposite the congruent sides also must be congruent. So these two angles must be congruent, but of course they must add to 60 to produce 180 degrees total, and so the two congruent angles must also be 60. So 60 plus 60 is 120, plus 60 is 180. These two angles have to have measures of 60 degrees, thus we have an equilateral triangle, which means the chord AB also has a length of 6 centimeters. Question 10. The sum of the squares of 3 positive numbers that are consecutive multiples of 5 is 725. We're asked to find the 3 numbers. This problem's pretty easy as long as we correctly set up the necessary equation. We're talking about consecutive multiples of 5. That means we've got some number that's a multiple of 5, and then we've got some consecutive multiples of 5. That means the next multiple of 5, which would be 5 times k plus 1, and the next multiple of 5, which would be 5 times k plus 2. That's the type of thing we're talking about. We've got the sum of the squares of these numbers. So what we should do then is square all 3 of them and add them together. And we're told that this sum of squares of consecutive multiples of 5 is equal to 725. Now we've just got to do some expanding, and we'll be dealing with a quadratic. After doing all of the expanding very carefully and then combining like terms, we arrive at this equation. Let's go ahead and subtract 725 from both sides. We're just trying to solve for k here, and then we'll be able to figure out what these 3 numbers must have been. So subtracting 725 from both sides is going to leave us with the same thing, except the constant term will now be minus 600. Now notice that all of these coefficients have a factor of 75. So we'll go ahead and divide everything by 75, which will leave us with k squared plus 2k minus, I believe it's 8, equals 0. And there we go. This thing is really easy to factor. We're going to have k and k equals 0, and the numbers here need to multiply to negative 8, and they need to have a difference of positive 2. So that's going to have to be k plus 4 and k minus 2. Thus, we have that either k equals -4 or k equals +2. So how do we pick between these two possibilities? Well, if we had k equals -4, then the three numbers we're looking for would be negative, like -20, and then this one would be -15, and so on. But we're told we're looking for three positive numbers. So we'll have to calculate those numbers with the assumption that k equals 2. Then our three numbers, and remember we were adding their squares in the first line, so the three numbers are these things being squared. If k equals 2, those three numbers are 10, 15, and 20. Question 11 is another internal choice question, and both options require construction. So we're here with the compass, and the straight edge should be a lot of fun. Let's do the first one first. We're asked to construct two concentric circles of radii 3 centimeters and 7 centimeters. Concentric means that they have the same center. I don't know how to do this without looking weird, but they have the same center. And we are asked to draw two tangents to the smaller circle from a point P, which lies on the bigger circle. So let's begin by constructing our two concentric circles of radii 3 centimeters and 7 centimeters. And I think those will fit on this paper, so that should be just fine. I'll try to put it near the middle here. So using my straight edge, I will measure out a radius of 3 centimeters. It looks about that big. And let me just move it over to the side a little bit and draw this circle. There is our circle of radius 3 centimeters, and the center is right there. So we'll use that same center for another circle that has a radius of 7 centimeters. Again, we'll measure out that radius using the straight edge. I'll just widen this right until there. That is 7 centimeters. So I'll go ahead and use this center as before and draw this circle of 7 centimeter radius. Now, our goal is to have two tangents to the smaller circle coming from some point on the bigger circle. It doesn't matter what point we pick on the bigger circle, but whatever point we choose, we're going to need to begin our construction with a segment from the center to that point on the larger circle. So since the point on the larger circle doesn't matter, let's just go ahead and draw a segment from the center to the larger circle, and where the segment hits the circle, that's going to be our point. And there we go. So where this segment hits the large circle, we'll mark that point, and we will call it P. Now, in order to get tangents to the smaller circle from this point, the first step is going to be bisecting this segment that we have just drawn. Now, in order to do that, we're going to bust out the compass again, and we want to measure out a length that's greater than half of this segment. Doesn't matter that much, it's just got to be bigger than half. So let's go with something like that. That looks good. And then from one endpoint of the segment, I'm going to just draw a little arc up here. I don't need a full circle, just an arc. And I'm going to do the same thing here on the other side of the segment. And then we'll do the same thing coming from the other endpoint of the segment. Using the same length in my compass, I'm going to mark this arc. And down below, I'm going to mark an arc as well. Now, if I connect the 2 points where these arcs meet, we will bisect the segment. So, using the straight edge, I'm going to connect this point here to this point down here, and that is going to bisect the segment that we have drawn. Now that we've bisected the segment, most of our work is done. All we have left to do is to draw a circle. We're going to draw a circle with this midpoint as its center, and the radius of this circle is going to be half the distance of the segment that we have drawn. So we can measure out half of the segment. Now that we've got the midpoint, it's going to look something like that. And we're going to draw a circle, and where that circle intersects the smaller circle will be our points of tangency. So again, this midpoint is the center, half the length of the segment is the radius, and now we'll draw a circle. Now we've got our circle. You can see how nicely it passes through the point P, and it passes through the smaller circle twice. These 2 points are the points of tangency. And so once we connect P, the point on our larger circle, to these 2 points, we will have constructed 2 valid tangents from this point P. So we'll go ahead and do that. First tangent is going to look something like that. I'll make it nice and bold since this is kind of the end goal. And then the other one from P to the second point, and it's going to look something like that. And there is our construction. We have constructed 2 tangents to the smaller circle from this point P on the larger circle. Now we'll do the alternate question for problem 11. It says, draw a pair of tangents to a circle of radius 6 centimeters, and those tangents should be inclined to each other at an angle of 60 degrees, and then we want to find the length of the tangent. The idea behind this construction is as follows. We're going to have a circle, and we're going to have 2 tangents going to the circle, and they're going to meet each other at an angle of 60 degrees. But over the course of our construction, we're not going to focus so much on the tangents. What you want to think about is the radii that go from the center of this circle to the points of tangency. We know that radii are perpendicular to the tangents that they meet, and so what we have here is a quadrilateral, and it's got these 2 90-degree angles. Now, a quadrilateral has an angle sum of 360 degrees. So if this quadrilateral has these 2 90-degree angles, and this 60-degree angle where the tangents meet, then the one in the middle is going to be 120 degrees. So we're going to begin our construction with this 120-degree concentric angle. Then we'll be able to construct 2 tangents that will necessarily be perpendicular to the radii. In fact, we will construct them to be perpendicular, and that's going to make them tangents. And then, of course, just because of how quadrilaterals work, they will have to meet at a 60-degree angle, since the quadrilateral will have to have an angle sum of 360. So here we go. I've measured out 6 centimeters on my compass, and now we'll draw this circle with a radius of 6 centimeters. Now that we've got our circle, I'm going to draw a radius, a segment from the center to a point on the circle. And this is just going to be the first ray of our 120-degree central angle. So it'll look something like that. And now I'll continue this with a dotted line, just so we can kind of see the line that we're working with. And we're trying to open up an angle here that has a measure of 120 degrees. To get an angle of 120 degrees, we can sketch a small circle here in the middle that's going to have the same center as the big circle. And this small circle is going to intersect this sort of diameter that we've drawn twice. So let's just get a nice small radius for our circle, and we're going to put it right here in the center and draw the circle. I'm not drawing the full small circle in the middle because we don't need the full thing. To get the 120-degree angle, I've still got the radius of this circle on my compass. So I'm going to go over here where the circle intersects my diameter, and I'm going to mark where my compass is intersecting the small circle I just drew. And that way I have measured out 60 degrees. So to get to 120, I need to go to this point that we just marked and do the same thing. See where the compass is hitting the small circle. Remember, the compass still has the radius of this small circle. Now, where this second mark hits the small circle, this is opening up an angle of 120 degrees. And if you're not sure why that is, think about regular hexagons and how they can be split up into 6 equilateral triangles. Now, to get this 120-degree angle, I'm just going to connect the center of the circles to this point of intersection that we just marked. Now, our goal is to construct a line perpendicular to the diameter that's meeting the circle here. And if it's perpendicular to that line, then it of course will have to be a tangent, because a line that's perpendicular to a diameter or radius is a tangent, assuming that it's passing through a point on the circle. So in order to do that, it will be helpful to continue this diameter a little bit outside of the circle, just to draw this dotted line to see how it continues. And then to get a perpendicular to this line at that point, we will bust out the compass once again and draw a small circle with this point as the center. And again, we really only need this circle to intersect the line. We don't really need the entire circle. So we'll just draw it enough to see those 2 points of intersection. Now that we've got the 2 points of intersection right here and right here, which I'll mark with the pencil, we can finish getting our perpendicular line. Now to do that, I'm going to increase the width of my compass just a little bit, and then I will put it right here where the circle intersects the line, and just mark an arc above the circle, something like that. And I'll do the same thing, putting the compass on the other point where the circle hits the diameter, something like that. Now, where these two arcs meet, that is the point which I need to connect to this point on the circle in order to get a perpendicular line. So let's go ahead and draw that. Connecting these 2 points is going to give us our perpendicular, which of course has to be a tangent, and it's going to look like that. I'll go ahead and mark this as a 90-degree angle, and we will repeat the same construction over here at the other ray of the 120-degree angle. We'll repeat the same construction in order to get a tangent, and then we'll have to continue that tangent so far that it will intersect this one. So I'll go ahead and just make the same construction over here. So we just have to start with a small circle and draw it in order to intersect the line twice. Now I will again increase the width of my compass, and I'll put it right here where this circle is intersecting this line. I think I can make it a little bit smaller, and we'll draw a little arc above the circle. We'll do the same thing, putting the compass over here, the other point where the circle intersects the dotted line, and where the two arcs intersect gives us the point that we need to connect to this point on the circle in order to get a perpendicular line, which is necessarily a tangent. So we'll go ahead and join these 2 points, and we can see where that's going to intersect the tangent that we previously drew. Now, labeling a few things, we will call this point up here A. We'll mark that this in here is a 120-degree angle, and we'll call this point down here B. The center of the circle we can call O, and the point where the tangents intersect we'll call P. We know that this angle has to be 60 degrees because this AOBPA is a quadrilateral, which has an angle sum of 360. So 90 plus 120, you're going to need another 60 degrees in order to make that 360. So we have finished the construction. We've got a pair of tangents to a circle of radius 6 centimeters, and the tangents meet at an angle of 60 degrees. So all that's left then is to find the length of the tangent. The question says the tangent. We of course made 2 tangents, but tangents to a circle from a common exterior point are congruent. So we could find the length of either of these tangents, and that would be fine. Finding the length of a tangent here will not be very difficult. In order to help us do this, let's split this quadrilateral into 2 triangles. So I'm going to join the points O and P with a dotted line just to help us see the two right triangles that we've got going on here. We've got this right triangle here and this right triangle here. And remember that the radius of the big circle is 6 centimeters, so these right triangle legs are 6 centimeters. As you might guess, these two right triangles are congruent. We know that by side, side, side. They have a common side here. These two sides are radii, and as we established earlier, the tangents from an exterior point have to be congruent. Since the two triangles are congruent and this big angle was 120 degrees, the smaller angles that belong to the two right triangles each have to be 60 degrees. That means that what we've got here are 30, 60, 90 right triangles. Now, in such a triangle, the ratio of the well, let me put it this way. In such a triangle, the side opposite the 60-degree angle, so this one, which is the tangent, is root 3 times the side adjacent to the 60-degree angle. That's true for any 30, 60, 90 triangle. I'll say it one more time. The side opposite the 60-degree angle, which is what we're looking for, is square root of 3 times the side adjacent to the 60-degree angle. So square root of 3 times 6 centimeters, and that is our final answer for the length of the tangents.
Here is question 12. We simply have a table giving us the age ranges of 300 passengers on a flight, and we want to find the mean age of the passengers. This isn't too difficult. What you've got to know is that to find the mean of grouped data, we simply act as if every data point is an interval midpoint, and then find the mean of that kind of made-up data set. So to start finding the mean, first, let's set up this little table where we'll have the midpoints of our intervals in the top row, and in the bottom row, we'll have the frequency of each interval. The first interval is ages less than 10, so that's between 0 and 10, and the midpoint of that interval is 5. That's the first midpoint. Then the next interval, less than 20. These counts actually include the previous group as well. We don't really want it to, so you just have to be careful here. We should treat this interval as going between 10 and 20. We will have to correct this count eventually since we're making a slight change here, but don't worry about it. It's pretty straightforward, so we'll cross that bridge when we get there. The midpoint, if we're going from 10 to 20, is 15. Moving on to the next interval, this one is from 20 to 30. Again, we'll have to correct that frequency in order to get rid of these other numbers because we don't actually want them there. But if we're looking at an interval between 20 and 30, the midpoint is 25. And then the next midpoint is 35, and so on. Now that we've got the midpoints listed, we just need to list the frequencies with which each interval containing the midpoints occurred. So for starters, between 0 and 10, the interval with a midpoint of 5, there were 14 passengers, so we put 14 there. Then between 10 and 20 is this number, 44, minus the number of people who were between 0 and 10. We just want the ones between 10 and 20, so we've got to subtract those people between 0 and 10. 44 minus 14 then leaves us with 30. Now for the next one, the number of people between 20 and 30, it's this number, 82, minus the number of people who were less than 20. So that's 82 minus 44, which is 38. And we proceed in a similar fashion to fill this table. The number of people between 30 and 40 will be 134 minus the people who are less than 30. So 134 minus 82. I've gone ahead and finished the table. So now we have all the interval midpoints and the frequencies with which those occur. Like I said in this remark, to find the mean, all we have to do is act like every data point is an interval midpoint. So we're sort of pretending that our data consists of 14 5s, 30 15s, 38 25s, and so on. So then to find the mean, all we have to do is add up 14 5s, add up 30 15s, and so on, as in this times this, plus this times this, and so on. That's going to give us a big total number, and then we just need to divide by 300, the total number of passengers, or the total number of data values. Of course, doing all this multiplication, 5 times 14, 15 times 30, and so on, and then the addition without a calculator would take some work. But there's nothing really hard about it, it's just time consuming. If you do all the multiplication and addition carefully, you will end up with 12,600. Then, like I said, we have to divide that by the number of passengers. It's just like the way we normally find the mean. Add up all the data values and divide by the number of data values. So the mean, x bar, is 12,600 divided by 300, which is 42, and that's the answer. Next up, question 13. I won't read this whole question, we'll just focus on the important pieces, most of which are given in this diagram, where we see that we have a lighthouse, which we'll assume is perpendicular to the ground, or the sea in this case, and we are told in the written problem that the lighthouse is 40 meters high, so if I write in perhaps red, this segment here is 40 meters. Now on the right, we have a ship at an angle of depression of 60 degrees from the lighthouse. On the left, we have a boat at an angle of depression of 30 degrees from the lighthouse. Now, the fact that the word problem uses ship and boat without ever being super clear about which is which is kind of frustrating. We're going to call this one the ship, though, and we're going to call this one with the sail the boat. It's a two-part problem, and again, a 30, 60, 90 triangle has some properties that we'll want to know to help us out with this problem. The first part of the question is which of the two, the boat or the ship, is nearer to the lighthouse, and we want to find the distance of that nearer vessel from the lighthouse. We can pretty quickly say that the ship is going to be closer because it has a greater angle of depression, an angle of 60 degrees. If it got closer, then it would have an even bigger angle, but that's pretty obvious. The closer an object is, the bigger that angle of depression is going to be. So the ship is the closer object. Let's go ahead and find its distance from the lighthouse. In order to do that, well, what are we looking for? We're looking for this distance here, BC. That's the distance from the lighthouse to the ship. And we know that this angle here has to have a measure of 60 degrees because the angle of depression is 60 degrees and these are alternate interior angles because we've got parallel lines here being cut by a transversal. So this angle has to be 60 as well, since the angle of depression is. And since this angle is 60 degrees, and we know that this leg of the right triangle has a length of 40 meters, we can use properties of 30, 60, 90 triangles in order to figure out the distance between the lighthouse and the ship. So if we call this distance we're looking for x, looking at this diagram of 30, 60, 90 triangles, we can see that the side opposite the 60 degree angle must be square root of 3 times the side adjacent to the 60 degree angle. In our case, that means 40 must be square root of 3 times x. And so we can say that the distance between the ship and the lighthouse must be 40 divided by the square root of 3 meters. And that's the answer to part 1. The ship is closer, and its distance from the lighthouse is 40 over root 3 meters. And if you're into approximations, this is about 23.1 meters. Let's move on to part 2, where we are asked to find the time taken by the boat, which is the other vessel that's further away. Find the time taken by the boat to reach the lighthouse if the boat's moving at a rate of 20 kilometers per hour. This is going to be a very similar problem. I'll go ahead and just shrink this work in red a little bit, and we'll write this next problem in purple. Now, if I could just please shrink this text. There we go, finally. Now, purple, and we'll answer this next question. So, how long is this side? That's what we want to figure out first. If we can figure out how far away the boat is from the lighthouse, it will be a simple calculation to figure out how long it's going to take to traverse that distance. Again, we'll use properties of 30, 60, 90 triangles. We know that this angle here has to be 30 degrees since this one is 30 degrees, and these are alternate interior angles. And then looking at our 30, 60, 90 triangle, we see that the side opposite a 30-degree angle must have a ratio of 1 over square root of 3 to the side adjacent to the 30-degree angle. So x, well, let's not call this x because we already used x. We'll call it y. Y, the side adjacent to the 30-degree angle, must be square root of 3 times the side opposite the 30-degree angle. So that's square root of 3 times 40. Now, this is in meters, and this is how far the boat needs to travel. How long is that going to take? Well, you may remember distance equals rate times time. So if we want to find the time that this is going to take, we'll need to take the distance, root 3 times 40, and divide it by the rate of travel. In this case, we are traveling 20 kilometers an hour, but this is in meters. So instead of dividing by 20, we'll divide by 20,000 because 20 kilometers an hour is 20,000 meters per hour. Doing this division of distance by rate, we get about 0.0035 hours. If we multiply this by 60, we'll get the number of minutes that is, and if we multiply by 60 again, we'll get the number of seconds. It's about 12.5 seconds. So our boat here is root 3 times 40 meters away from the lighthouse, and going at a speed of 20 kilometers an hour, it will take about 12.5 seconds to reach the lighthouse traveling at that speed. Finally, we arrive at the last question. We've got some good context here about Krishnanagar clay dolls and some pictures of those dolls, but let's jump into the math and try to wrap this up as quick as we can. This is another two-part question. The first part is asking us what the ratio of the surface areas of red spherical apples in doll 1 to the spherical oranges in doll 2 is. What is the ratio of those surface areas? Well, let's read this information. We're told that the ratio of diameters of the red spherical apples in doll 1 to the spherical oranges in doll 2 is 2 to 3. That's the ratio of the diameters. So how can we use that to find the ratio of the surface areas? Well, naturally, we need to know how to find the surface area of a sphere. And it's not very complicated. It's just 4 pi r squared. That's the surface area of a sphere. Let's use r1 to denote the radius of the red apples, and we'll use r2 to denote the radius of the oranges. So if I want the ratio of their diameters, or the ratio of the surface areas, we know the ratio of the diameters. If we want the ratio of the surface areas, we'll just write this fraction, 4 pi r1 squared, the surface area of the apples, divided by 4 pi r2 squared, the surface area of the oranges. This is the ratio of the surface areas. Now we just have to simplify it a little bit.
Let's go ahead and cancel out the pi's. The pi's will cancel out. We could cancel out the 4's as well, but instead, let's rewrite it like this. Notice that 4 is 2 squared. So I could write this as 2r1 squared divided by 2r2 squared. Because we cancel out the pi's, and then 2r1 squared is 4r1 squared, and similarly in the denominator. Now, why would I write it like this? Well, because 2r1, 2 radii, that is the diameter of the apples. This, 2r2, is the diameter of the oranges. So then finally, we could rewrite this as 2r1 over 2r2 and just bring that squared exponent outside like that. And right here, that's the ratio of the diameters. Diameter of the apple, diameter of the oranges. And we were given that ratio is 2:3. So this has to be the square of 2/3. Works out pretty nicely. And so our answer, the ratio of the surface areas, is 4:9. Now let's move on to the second part of the final question. The blue doll of doll 3, so this one here, is melted and its clay is used to make the cylindrical drum of doll 4. If the radius of the drum is also 3 centimeters, find the height of the drum. Certainly, if the clay from doll 3 is used to make the drum in doll 4, their volumes have to be the same. So let's go ahead and calculate the volume of doll 3, and we'll be able to use that to answer our question. Details about doll 3 are given here. We're told that it has a cylindrical body and a spherical head. The spherical head has a radius of 3 centimeters. So let's write V for volume of doll 3. It is equal to 4/3 pi r cubed. This is the head. 4/3 pi r cubed. R is 3 centimeters. So for r cubed, let's just write 27 for now. We'll worry about units in the end. 4/3 pi times 3 cubed, so that's 27. Then we need to add the volume of the cylindrical body, which is pi r squared times the height. That's the area of the base times the height. Pi r squared is pi times 9 because we're told the cylindrical body also has a radius of 3 centimeters. So that's pi r squared. Then we need to multiply by the height, which we're told is 8 centimeters. So multiply by 8. Now this is equal to 4/3 of 27 is 36. So 36 pi plus, how many more pi's do we have? 9 times 8, so 36 plus 72 pi, which is 108 pi. This is the volume of the blue doll 3. Now we'll set that equal to the volume of the cylindrical drum and solve for the height. We are told that the radius of the cylindrical drum is also 3 centimeters, so the volume of the cylindrical drum will be pi r squared, which is 9 pi, times the height, which is what we're looking for. And this, well, since it came from the clay of doll 3, it must have the same volume as doll 3. So this is equal to 108 pi. And so we find h by dividing both sides by 9 pi. 108 pi divided by 9 pi is simply 12. And of course, we should recall that our units here are going to be centimeters. So the height of the drum in doll 4 is 12 centimeters. And that concludes this Class 10 Term 2 Sample Basic Mathematics paper. If the video was helpful, share it with some of your friends. I hope you liked it, and feel free to let me know in the comments if you have any questions or video requests. See you next time.